Hi, I'm Rob Simmons, Product Manager with Garrett Advancing Motion. The topic I'm going to present is turbo system optimization. While turbocharger selection is a critical part of your project, selecting the correct mating components is equally as important. Optimizing the entire system ensures that the engine will make the target horsepower and everything functions properly. What I hope you take away from this is not only a better understanding of turbo system components, but also where you can find this information for future use in projects. The areas that I'm going to cover are based on questions that we've received during trade shows and races, as well as areas I feel are commonly overlooked. So let's get started. It is important that the air filter is sized for the maximum flow rate of the application. The target face velocity is equal to or less than 130 feet per minute at redline to minimize restriction. As excessive restriction can cause oil leakage at the compressor side piston ring, which results in oil loss, a fouled charge air cooler, and potentially smoke out of the tailpipe. Excessive restriction can cause an increased pressure ratio, which can lead to turbo overspeed. This overspeed then can reduce turbo durability and can result in an early failure. How do we determine the correct air filter size? For this example, the face velocity equals 130 feet per minute, the mass flow for our 400 horsepower application, 40 pounds per minute, and air density at sea level. The formula that we're going to use, mass flow equals volumetric flow rate times air density. We want to solve for the volumetric flow rate, so this equals the mass flow divided by air density. Using the values for our example, the flow rate, the volumetric flow rate would equal 526 cubic feet per minute. If you have a twin turbo application, you would divide that flow rate by 2. Now we need to solve for the area. Using the formula face velocity equals volumetric flow rate divided by area, we solve for area, which equals volumetric flow rate divided by face velocity. Using our 526 cubic feet per minute volumetric flow rate divided by our face velocity target of 130 feet per minute, this equals an area of 4.1 feet squared. To convert this into inches squared, multiply by 144, that equals an area of 582 squared inches. Now that we have the required calculated area for the filter, we need to determine the correct filter to use for the application. In the chart to the right are some specifics on number of pleats, pleat height, pleat depth for some common filters. So for our example, we're going to use the pleat height of 9 inches, pleat depth of 0.55 inches, and number of pleats of 60. To calculate the area of this filter, you take the pleat height multiplied by the pleat depth times the number of pleats, and then multiply that by 2, since there are 2 sides to the pleats. Multiplying these together, the area equals 594 inches squared. Considering that 594 inches squared is greater than our 582 inches squared for the required filter, this filter is appropriate for the horsepower and the application. This concludes the video presentation. I hope you found this information helpful. As I mentioned at the beginning of the presentation, this information is available on the Garrett Motion website, along with other general and technical information. Thank you for your time, and good luck with your future turbo projects.